to True Projects. In this video, we are going to discuss about the project which is Advancing Bankruptcy Forecasting with Hybrid Machine Learning Techniques, Insights from an Unbalanced Polished Data Set. So before getting into the execution, let us understand what is the project about. So what is this bankruptcy according to you? So bankruptcy is when people or when businesses, when they can't pay their debts by their own, they ask law for doing help. What does this law do? It will help them reorganizing their debts or it will sell their assets to pay what they owe. So why predicting this bankruptcy important? By doing so, it will help us to see if a company might go out of business. And if we know this early, we can try to fix things and avoid bad stuff like people losing their jobs. So there are two main types of bankruptcy. One is Chapter 7 and the other one is Chapter 11. So coming to the Chapter 7, Chapter 7 means that selling everything to pay debts, which means that if a person is bankrupted, he has to sell all the things that are assets to pay the debts. Moving on to the Chapter 7, it means that making a plan to pay debts over time. So, to predict this bankruptcy, researchers have developed the methods called statistics to advanced machine learning techniques. These methods they are tested using both the data sets that are balanced as well as unbalanced. But these methods they performed well only on balanced. They could not perform well on unbalanced. But the problem here is achieving a balanced bankruptcy data set in the real world is impractical. As equal number of bankrupt and non-bankrupt companies can be tough, often there are ways more healthy companies than those in financial trouble. So this necessitates strategies to address data imbalances to predict modeling that are predictive modeling. So in this project, we are going to address the challenge of bankruptcy prediction, which is crucial for financial stability and risk management. Specifically, we are focusing on improving the accuracy and reliability of bankruptcy forecasting by utilizing hybrid machine learning techniques on an unbalanced data set of polished companies. So the author in the base paper, he has proposed a technique called hybrid machine learning to predict the bankruptcy. And this hybrid method, it comprises, that is, it combines two methods that are extreme gradient boosting, that is XGBoost, and artificial neural network, which is ANN, to handle large data sets for better decision making in businesses. And the parameters in this model, they are optimized using genetic algorithm and particle swarm optimization. So to further improve the performance, we have employed the technique called voting classifier, which is an ensemble technique. This technique, it consistently outperforms individual models, leading to its deployment in the front end. So moving on to the flow of the project, first we have imported the dataset called polished bankrupt dataset. After importing, we explored it for understanding what kind of information it contains. And then we pre-process this dataset. Here we have converted dataset into Pandas data frame and we removed columns that are not useful for predicting bankruptcy. And then we did label encoding, that is, we have converted categorical variables into numericals so computers can understand them better. Then we decided which features that are the columns are most important for predicting bankruptcy. Then we splitted the data into train and test sets. So train is for training the models and test is for testing how well the model works. Moving on, we built the classification models using two techniques, that is genetic algorithm and particle swarm optimization. These techniques, they helped in finding the best settings for the models to make accurate predictions. Then we teach the models how to predict bankruptcy using trained data that are after models are built. Then we train those models on the pre-processed dataset. Then we have evaluated those models using accuracy, precision, recall, and F1 score. So after evaluating and selected the best performing model, that is voting classifier, we used Flask framework with SQLite to create a web application for deploying the project. This allows users to use their bankruptcy prediction model, which we have built. So moving on, to implement this project, we need software and hardware requirements. And the software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So moving on to the hardware requirements, we need Windows operating system, i5 and above processor, 8 GB and above RAM, hard disk of 25 GB and above. Moving on, these are the models which are built in the project. The last model, which is voting classifier, is proposed by us. Hybrid model, which is XGBoost with ANN, is proposed model in the base paper. So along with voting classifier, we also build the other models to compare how well this voting classifier is performing well than these models. So let us understand what is this voting classifier. It is an ensemble technique and it will combine predictions from multiple individual models. Here in this project, we have combined bagging classifier with random forest and decision trees. Each model, it generates predictions whether a company will go bankrupt based on various features and historical data. The voting classifier then aggregates these individual predictions from bagging classifier, random forest, and decision trees using methods like majority voting or weighted averaging to make a final decision about whether a company is likely to face a bankruptcy. By leveraging the diverse perspectives of multiple models, the voting classifier it aims to improve the accuracy and reliability of bankruptcy predictions, potentially surpassing the performance of any single model. So, as voting classifier is performing well, we have deployed it in the front end. So now we will execute the project. To execute it, first we have to open the code folder which contains source code files. So these are the source code files in the code folder of the project. So now let us understand each file. How will it be used in the project? So here in the first folder, we have the data set of Polish companies. This is the first year data set. Here the second year, third year, here comes the fourth year, and the last one is fifth years. So in the first year, this is the data which contains in the first year file. So this data is related to first years of Polish companies. And here we can see all the features are renamed as attributes. It is just for confidential purpose. So now close this. Similarly, we have in second year also. This is the raw data of Polish companies second year. Close this. Similarly, we have in third year, fourth year, and fifth year. And the data from all these files will be pre-processed. And here we get the final process data. So these are the features. We have 64 features. And this is the data. Here comes the target variable, which is bankruptcy will be predicted or not predicted. So here we have two classes that are 0 and 1. Here, 0 refers to bankruptcy not predicted, that is not detected, and 1 is it is bankrupted. Now close this. Here in the sample folder, that is sample file, we have the test cases using which will be predicting bankruptcy in the front end. So we use all of these test cases to predict bankruptcy. So now close this. Moving on to the static folder. This folder contains files related to project styling and interactivity, which are CSS, JavaScript, and Bootstrap files. These resources are crucial for enhancing the visual appeal and functionality of the project's web interface. And the next folder is templates folder. Here lies all the HTML pages utilized in the project, and they are index.html, about.html, and each HTML file represents a different page of the website and provides the structure and the layout for displaying content to the users. This is app.py file. This .py file, which is Python file, encompasses front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. These are two model files which contain the algorithm information and they will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is signup.db file. This file is the database file which is used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. So here we need to type the command cd followed by the space, and now we need to paste the copied path, then click on enter. This will change current directory to the code folders path. So here we can observe that current directory is changed to the code folders path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and it will perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is localhost and the port, unless configured differently. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So first we need to sign up. So click on sign up link and enter all the registration details if we are registering newly. I have already registered and I have an account in it, so I will directly sign in. Here we need to provide username and the password. So I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page. So here we can see the parameters, which are attributes, need to be entered. Based on the provided attributes, we'll get the prediction whether company is bankrupted or not. So let's enter them. Here in the Excel sheet, we have test cases from the sample file. So we will use these test cases to predict the bankruptcy in front end. So first we'll try with the first test case, which is not bankrupted, and see how will it correctly predict. So the first attribute is 0.84524. So I'm copying it. The next one is attribute 2. So I'm copying it. Attribute 3. Attribute 4. Attribute 5. Attribute 6. Attribute 7. Attribute 8. Attribute 9. Attribute 10. Attribute 11. Attribute 12. Attribute 13. Here all the parameters are entered. Now click on predict. Here for the provided input, we got the prediction that Polish company is not bankrupted. So now we will enter other test case. So we will try with the second test case. Here is the attribute 1. Moving on to the second attribute. The next one is attribute 5. Attribute 6. Attribute 7. Attribute 8. Attribute 9. Attribute 10. Attribute 11. Attribute 12. Attribute 13. Here, the class which has to be predicted is 1, which means that it has to be bankrupted. Now we will see how correctly it will predict. So click on predict. Here it has correctly predicted that the Polish company is bankrupted based on the provided input. Now we will give some more test cases and see how well correctly it will predict. Click on prediction. I entered all the attributes from sample file. Now click on predict. Here we got that Polish company is not bankrupted for the provided input. So now we'll try using other test case. So click on prediction. Here I have entered all the attributes. Now click on predict. Based on the provided information, here we got the prediction that the Polish company is going to be bankrupted. In this way, just by entering the parameters to the system, it will predict whether company will be bankrupted or not. Now we will see the graphs of the project. So click on graph link. So here we have sample outcome graph, which displays the distribution of labels. Here, red color represents non-bankrupted cases and blue color represents bankrupted cases. And here we have the graphs for models built after feature selection. This is accuracy comparison graph, where x-axis represents accuracy score of each algorithm and y-axis represents algorithm names. This is precision score comparison graph. This is recall score comparison graph. Here we have FN score comparison graph. This is AUC sensitivity. Moving on, here are the models built for all the features. And this is the accuracy graph for that. Here on the x-axis, we have accuracy score for each algorithm, and on y-axis, we have algorithm names. Here is the precision score comparison graph. This is recall score. And here we have FN score, AUC, sensitivity. Now click on sign out.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.